Hello, Lompo video. This one is on rates. Ethyl ethanoate is hydrolyzed slowly by water in the following acid catalyzed reaction. There you go. The concentration of ethyl ethanoate was determined at regular intervals. As the reaction progressed, the two separate experiments were carried out with different HCl concentrations. The following graphs show the results of an experiment using HCl 0.1 molar. Okay, and it gives you a blank graph, or it gives you a graph with this one. This graph, and then it says when the experiment was carried out at 2 molar or 0.2 molar, we get these results, and I've plotted them there already. Not very well, but there you go. Interestingly, why can we do this? Well, the other reagent is water, and because water is a solvent, it is in large excess. And if it's in large excess, the concentration doesn't change. So the concentration of water is constant. Okay, so we can assume that the water doesn't change. It's just the ethyl ethanoate that changes. Anyway, so there you go. I've drawn the graph. All right, I'm sure you can all do that. Then it wants to use one of the graphs to show that the reaction is first order with respect to the ethyl ethanoate. Draw construction lines. Now I'm obviously going to use their graph in case my graph's not very good. So I would use construction lines here. Let me use this pen, and I'd go from point 2 to point 1, and I go across here, not very well, but you know what I mean. I draw a line there, and I go down here. Oh, that's not good, is it? And I get, I don't know, 65 seconds as the first half-life. The second half-life is from point 1 to point 0.05. I'd go across here. I'm sorry if let me see if I can get a thicker pen, because it's not very good, is it? This is probably too thick now. So I go along here at 0.05, right at the end, and I get 130. Okay, so the first half-life is 65, and from here to here is another 65 seconds. And the whole thing is, what you're supposed to know, as I'm sure you will do, that if the half-life is constant, therefore it must be a first order reaction with respect to the ethyl ethanoate, because that's the thing we're looking at. Hope that makes sense. So that's how we show its first order. Okay, so that's that one done. Next one, use the graphs to calculate the order of reaction with respect to the HCl. Show you working. Now, obviously, we know the first graph. Let me use my black again. This one. This one is 0.1 molar. And the second one, the one we've drawn, is 0.2 molar. Now, which one is faster? Well, our one is faster because the gradient is more in our one. So let me have a look at the question again. Are there any clues? Use the graph to, it just says calculate the order of reaction. Okay, now what you do now, I'm going to get my ruler out. Oh, ruler is coming soon. All right, so we haven't got a ruler. But what I would do is I'd find the slope of both graphs at the start. Now, without a ruler, it's impossible. It's really hard for me. Draw a straight line there, and then do it for our one. Straight line there. Find the gradients of these two, this one and this one. And the gradient, one gradient over the other, gives you the order, doesn't it? Whoops, that wasn't intentional at all. Okay, so which one's going to have the greatest gradient? Our one. Okay, so it's the gradients. Where are we? Gradients, the steepest gradient, the biggest one, in other words, divided by the less steep. Okay, it's going to give you the order, isn't it? Why is that? Well, because the gradient is the rates at 0. The steepest gradient is the rate at 0.2. The less steep is the gradient, and the rate at 0.1. So you've doubled the concentration of HCl, and therefore you're going to, what am I trying to say here? You're doubling the concentration of HCl. So the different rates, the ratio of the different rates will give you the order with respect to HCl. Okay, and as you can see, even though I've done it very, very badly, whoopsie daisy, why isn't that working? Oh, there you go. As you can see, I haven't done it great, but you can see that it's 100 here, Whoops, everything's going wrong. This is about 100. And this one, look, it's not 60, is it? But if I did it nicely, it would be about 50. So the value of the rates is about 100 because this distance is the same, isn't it, for both? So it's about 100 divided by 50. So the rate is, sorry, the doubling. Oh, what am I trying to say here? 100 divided by 50 gives you a twofold. So it's speeded up by twice as fast. Okay, I'm messing this up big time, but I hope you get it. I don't want to re-record this. But what we're doing is we found the rate at the steepest one. We found that's whatever you find it is. That's the gradient of the first one, divided by the gradient of the second one, and you get it's twice as fast when it's zero point 0.2 molar. Therefore, we have doubled the concentration of HCl, and the rate has doubled. Therefore, it must be first order with respect to the HCl. I hope that makes sense. I know I made a mess of that, haven't I? So this isn't the order. This doesn't give the order at all. I shouldn't have said that. It just gives you the ratio of rates. And since we doubled the H plus in the what we did the first one, we used that, and the second one we used twice the H plus. And what happens? The rate of the first one was 50, say, and the second one the rate was 100. So we've doubled the concentration of H plus, and the rate is doubled. Therefore, it must be first order. I made a big mess of that, but I hope you make sense. So it's first order with respect to HCl. Okay, now let me do this. I can't remember what question that was. I think this is the next one. Yeah, there you go. Right, so let's see if we can finish this off. Sorry about that. I understand I didn't answer that very clearly at all. But if you have a problem, give me a shout. Write the rate equation and calculate the value for the rate constant. Right, the rate equation is going to be some constant. Now, I think it was the ester. It was first order with respect to the ester and first order with respect to the HCl. I think that's what we found, wasn't it? Yeah. So it's first order with respect to both of them. Okay, and there you go. It's just the HCl and the ester. All right. We didn't do anything with the water, so we can't tell if water makes a difference, and the water's kept constant anyway. So there you go. That should be easy. Write the rate equation for the reaction and calculate the value of the rate constant. Right, now you use your gradient here. Gradient for one of your graphs. I'd pick the one that they drew. Is equal to K, that's the unknown. Now you know the concentration of the ester. I think it was 0.2, something like that. And you know the concentration of the HCl was like something like that, 0.1. So you can find the K here, and this is the gradient for their graph. Okay, I hope this is making sense. I'm rushing through this a bit, but if it doesn't make sense, give me a shout and I'll redo this one. Why is it not possible to determine the order of reaction with respect to the water? Because water is a solvent, okay, and the concentration of water is constant, as we've said. So we can't change the concentration of water because it's always the same, isn't it? Concentration of water is always the same, so we can't do this. Although the ester decreases during each experiment, HCl remains the same as the initial value. Okay, so in other words, this doesn't change as the reaction goes on. Why is this? Well, that's pretty obvious. If the concentration of something doesn't change, but it affects the rate of reaction, it is obviously acting as a catalyst, isn't it? All right. Anyway, I hope that makes sense. Again, if I've made a mess, give me a shout and I'll redo this one. Thank you.